My name is John Swygert. I am a scientist, a researcher, and an author. And I am the author of the Swygert theory of everything AO. Today I want to explain something unfolding across modern Appalachia that most people see every single day, yet never fully understand. It looks like random tree die-offs. It looks like isolated pest. It looks like climate stress. But when you examine it from the proper scientific axis, the encoded equilibrium axis defined in the Swygert theory of everything AO, something very different emerges. A single repeating biological sequence, a unified collapse pattern, a law, across lilac, ash, and pine, three species that share no close biology, no shared ancestry, and no overlapping ecological niche. The same multi-stage breakdown appears with mathematical consistency. It begins long before anyone notices anything wrong. It begins quietly, invisibly, at stage 1, Precursor insect assault. This is the most important stage in the entire model, and it is the one almost everyone overlooks. Lanternflies, emerald ash borers, pine borers, longhorn beetles, turpentine beetles, dendroctonus. All of them begin the collapse by penetrating phloem, xylem, or sapwood. They don't just eat, they destabilize the tree's encoded equilibrium. When the insect pierces the tree loses energy, loses encoded order, loses the chemistry that maintains its immune system. This is not damage, it is destabilization. Stage 2 begins the moment encoded equilibrium narrows. The antifungal chemistry that protects the bark declines. The energetic balance between hydration, transpiration, and immune response begins to wobble. This is measurable and predictable. The tree becomes vulnerable not because of the insect's presence, but because its encoded equilibrium has been weakened. In TSTOEAO terms, V equals E times Y shifts downward. Its capacity to maintain order decreases. This part is critical. Everything that follows is not the cause of collapse. It is the consequence of collapse. Stage 3 is opportunistic colonization. Once microcracks form and antifungal defenses weaken, the world rushes in. Sooty mold on lanternfly-covered lilacs. Lichen growth that traps humidity along stress lines. Blue-stain fungi in the sapwood of collapsing pines. These organisms are not predators, they are opportunists. They sense the encoded weakness, not the visible damage. They do not cause the decline, they signal it. Stage 4 is penetration into vascular tissue. Saprotrophic fungi breach the cambium. Decay fungi enter SAP channels. The structural integrity of the organism collapses from the inside out. The tree still looks externally stable, but internally it is already gone. People see green leaves, but the organism is already hollowing. Stage 5 is what the public calls sudden death. The rapid browning. The bark peeling off in sheets. The cracking, splitting, and falling. To the untrained eye, it looks like a single event kill, but what appears sudden has been in motion for years. Nothing is sudden. Everything is patterned. Let me show how the pattern appears in 3 different species. Lilac collapse begins with lanternfly probing. Their phloem tapping drains the metabolic reserves the lilac needs to maintain encoded order. Honeydew deposition promotes sooty mold, which suppresses photosynthesis and increases surface moisture. Lichen growth then stabilizes humidity along weakened bark. Saprotrophic fungi breach the softened cambium. Stems 3 to 4 inches thick rot through in under a year. This fulfills every stage of the AO multi-stage botanical collapse model with perfect alignment. Ash collapse begins invisibly. Emerald ash borer larvae carve SC-shaped galleries inside the phloem. The tree looks healthy until transport chemistry collapses. Carbohydrate movement stops, antifungal chemistry drops. Secondary fungi and lichens colonize the destabilized bark. Eventually, bark sloughs off in sheets. Entire forests collapse in 1 to 3 seasons. The sequence matches the lilac axis exactly. Pine collapse is the longest and most complex, but again, it follows the exact same law. Pine borers, longhorn beetles, dendroctonus species all begin with deep galleries inside phloem and sapwood. Resin defenses collapse as encoded equilibrium drops. Blue-stained fungi flood borer channels. Crowns brown suddenly. Trees disintegrate in months. 3 unrelated species, all aligning on one axis. When you plot these species along the AO axis of precursor insect assault, immune collapse, opportunistic colonization, vascular breach, rapid structural failure, the alignment becomes undeniable. 3 species, 3 families, 3 different ecological roles, 1 law. This paper and this framework exposes what single-cause models always miss. Insects are not the end of the collapse. They are the beginning of the collapse. Once they destabilize encoded equilibrium, the rest of the sequence is mandatory. The decline becomes deterministic. Why does this matter? Because if we continue treating these events as random infestations or fungal outbreaks, we will always intervene too late. We will always focus on symptoms instead of causes. We will always lose the battle. If we detect stage 1 early, that's before antifungal chemistry collapses, before opportunists appear, before vascular breach, we can actually save trees. We can interrupt the encoded destabilization phase. That is where management must begin. This framework also reveals something deeper. The same collapse pattern that killed lilac, ash, and pine almost certainly killed the American chestnut. Not as a single blight event, not as a lone fungus, but through the same multi-stage insect-driven immune collapse we see today. The companion paper will establish that fully. The Swygert theory of everything AO shows that ecology isn't chaotic. It isn't random. It follows encoded equilibrium laws. Species collapse is not a mystery. It is a pattern. Once you know the pattern, you can predict it. Once you can predict it, you can prevent it. This is the first time anyone has unified these arboreal collapses into one scientific law, and it will not be the last.